Okay, for number 3, this is a paper review for MAC 1105, test number 3. For number 3, it says, for the quadratic function f of x equals 3x squared plus 24x plus 45, part A, does the function have a maximum or minimum? If so, where? How do you know if it has a max or min? State the domain and range of the function, and then it goes on to number 4. So let's do number 3. All right, to find the maximum and minimum, we have to look at two things. First of all, we have to find the vertex, because that will be either the highest point or the lowest point of a quadratic, right? So we know this is quadratic. So the vertex can be found by taking negative b over 2a. A in this case equals 3, b equals 24, and c equals 45. So b is negative 24 over 2 times a, which is 3. So negative 24 over 6 gives me a negative 4. That's my x value. To find the y, I have to find my function at negative 4. So that becomes 3 times negative 4 squared plus 24 times negative 4 plus 45. Okay, so negative 4 squared gives me 16. And then we have a negative here. I got 96. And then plus 45. So let's do this together. 3 times 16 gives me 48. 48 minus 96 plus 45 is what we're after. And when I do that, I get a negative 3. So my vertex is at negative 4, comma, negative 3. Now, does a function have a maximum and minimum? It does have a minimum, and I know this because the coefficient of x squared is positive 3. So that means that the parabola opens up. Looks like that. And at the bottom is the vertex. So if it opens up, we're going to have a minimum. And again, where does it happen? It happens at negative 4, 3 at the vertex. State the domain and range of the function. Okay, so the domain. I do not have any kind of fractions or anything that looks like a fraction. I have a simple polynomial. The domain is all real numbers. There isn't a place where it zeroes out. And the range. Now the range, remember we have a minimum. So we're going to look at the y value. So the minimum is at 3. So the range starts at 3 and goes up to positive infinity. And how do I know that? Again, the vertex is the base of it. So if the vertex is negative 4, 3, the range is my y value. So it goes 3 and upwards. Okay. Number 4. Use the leading coefficient test to determine the end behavior of. We got to figure out if the left of the graph rises or falls, and if the right of the graph rises or falls, and how do I know this information? Okay. To figure out if it rises or falls and what the end behavior is, you have to look at the leading coefficient. The leading coefficient is positive 4 x to the 6th. The leading coefficient has x to the 6th, which is even. So that means it's either both are opening up or down. Okay, so to do a little bit more research on that to figure out, hey, is it opening up or down, you have to look at the value of the leading coefficient, which is 4. So 4 is positive. So it's opening up in both directions. So it looks like that. Okay, so the left of the graph is going to rise and the right of the graph is also going to rise. And again, how do I know this information? Because I used the leading coefficient and found the power to be an even power of 6. 6 is even. And then I did further exploration by looking at the leading coefficient of 4. 4 is positive, so they both are opening up in both directions. Okie dokie. That was 3 and 4. Alright, I'm going to start the next video on 5 here. So thanks for watching 3 and 4.